Hi everyone, welcome back. Today we're going to do 9.2.4, which focuses on real numbers. There are two types of real numbers that we're going to be talking about today. So the EQ for today is what kind of number is it? Okay, and let's take a look at the lesson objective. It says that students will distinguish rational numbers from irrational numbers. Those are the two types of real numbers that we have. They will convert terminating and repeating decimals to fractions. Terminating means the decimal will end. Repeating decimals means it's the same numbers repeating on and on forever. They will also use rational approximations of irrational numbers to compare the size of irrational numbers and locate them on a number line. Basically, that's just saying we're going to try and place rational and irrational numbers on a number line and see where they go. Okay, so we're going to do 8 problems today, 100 through 108. Actually, I guess that's technically 9 problems. Okay, so let's just read through this. Any number that can be written as a ratio of two integers a over b, where b cannot equal 0, is called a rational number. So b can't equal 0 because you can't have 0 in your denominator of a fraction. A rational number can be matched to exactly 1 point on the number line. There are many other points on the number line, however, for which there is not a corresponding rational number. These numbers are called irrational number. Numbers such as pi, square root of 2, negative square root of 5 are irrational numbers. So in other words, irrational numbers are decimals that repeat forever and they don't have a particular pattern. They're just random numbers. So if you punch in pi or the square root of 2 on your calculator, you're going to get a decimal that just goes on forever. The rational numbers and irrational numbers make up all of the numbers on the number line and together are called the real numbers. Okay. In this lesson, you will learn how to identify a number as rational or irrational. You will always also write decimals as fractions to show that they are rational. Then you will compare these kinds of numbers and place them on a number line. Okay, let's just jump right into 9-100 here. It says in previous courses you work with decimals that repeated and terminated. All of these are called rational numbers because they can be written as a ratio like 2/3 and 5 over 1 equals 5. Because the square root of 9 equals 3, the square root of 9 is also a rational number. However, there are some numbers that do not repeat or terminate when they are written as decimals, such as the square root of 2. Such numbers are called irrational numbers. So if you look at that example right there, it's printed on the right, that is an irrational number because the square root of 2 is 1.414213562237 dot dot dot. It goes on forever. There's no pattern that you can predict where it allows you to predict the next number. An irrational number cannot be written as a ratio of any two integers. In other words, an irrational number cannot be written as a fraction. So again, at this point you should be able to identify that ratio and fraction are the same thing. Use your calculator to find the square root of the following numbers. Decide whether the numbers are rational, which has decimals that terminate or repeat, or irrational. Pause the video right now to grab a calculator and find your answers to A, B, and C and write down if they are rational or irrational. Alright, welcome back. And let's take a look at the results here. So the square root of question A says the square root of 6.25, the answer is 2.5. So is that a rational or irrational number? Well, this one is going to be rational because it has a decimal that ends. It's just 2.5. That's it. You can actually write that as a fraction, and we'll talk about how to do that later. The square root of 100 is just 10, and that number ends. It's just 10. It's not a decimal that goes on forever. So I'm going to write an R for rational. And question C is the square root of 7. The answer here is a bit more complicated. It's 2.645751311 dot dot dot. That's what my calculator shows. Because there's that dot dot dot, it's telling me that this number goes on forever, and I don't know what's after that. So this one is going to be irrational. Okay, so when it's dot dot dot, it goes on forever. You don't know what's next, basically, right? So I think of it as a person who's being irrational. They're they're not making sense. You don't know what's going to come out of them next. So kind of think of it along the same ways if that helps you remember it. An irrational number is an irrational person. You just don't know what's expected. Okay. Okay, let's move on to the next problem, 9-101. Says, do you think that you can decide by looking at whether a number is rational or irrational? You will explore this idea in parts A through D below. So it says here, without doing any calculations, I want you guys to make a prediction of which ones you guys think is rational or irrational. Just write R for rational, I for irrational. Okay. So pause the video right now. There are 8 numbers that you see on problem A. Just make a quick prediction whether you think they are rational or not. Okay, go. Okay, now for question B, it says to use your calculator and write the equivalent decimal for each of the answers on the list, and then see if your answers are correct. Okay, so I'm going to do the first one for you. And the first one, -5/9. So if I were to do 5 divided by 9 on a calculator, I get -5.555555555 forever, right? And there's another way you can write that. It's just going to be a -0.5 with the bar over it. Okay, that bar tells me that the number that the bar is over, which is currently over the number 5 right now, that number is going to be repeated forever, and it goes on forever. Okay, so again, pause the video. I want you guys to answer the rest of those questions. See if your initial predictions were correct, if these were rational or irrational. This first number here is actually rational. Excuse me. It's rational because you can write it as a fraction. Anytime you can write it as a fraction, it is rational. All right, so let's look at the square root of 7. We already talked about that. It's going to be irrational. It's 2.645751 ... Goes on forever. We can't make a prediction of what comes after that. Next problem is 21/4. Reduces in decimal form to give us an answer of 5 1/4, 5.25, and that number ends, and so it's rational. Again, with that one, it's written as a fraction, so anytime you can write it as a fraction, you already know that it's rational. Okay. The next number is negative square root of 15. The square root of 15 is 3.8729 ... And just because it's a negative, it doesn't make it rational or irrational. It's just, you can still have negative rational and irrational numbers. But the fact that it's ... and it goes on forever, that will make it irrational. Let's just go to the number directly below in scientific notation. Your final answer is going to be -0.064, and the decimal ends, right? There's no ... so it's definitely going to be rational. Let's go to the next one to the left. 730/99, it's 7.373737373737, and it goes on forever. So now, this one is a tricky one. Because it goes on forever, you might think that is irrational, but technically, it's the same number as 7.37 with the bar over it. So that means it's a repeating decimal. And because it's a repeating decimal, I can make a prediction of what comes after that 3.37. It's going to be another 37, another 37, and another 37. So because of that, I know what's coming next. It's going to be a rational number. To the left in pink there, it's negative 8.7179 ... It's going to be irrational. And it looks like I skipped one here. So let's go to pi squared. Well, pi is already an irrational number. So if you square an irrational number, in other words, an irrational number times an irrational number, or you multiply anything by an irrational number, it's still going to be an irrational number. Okay? So, again, if the decimals repeat, like -5/9 and 7.37 with a bar over it, that will be rational, okay? But when the decimals go on forever and there's no rhyme or reason, there's no pattern to it, it's going to be irrational. Okay, so let's go to question D here. It says the square root of 42.25, is that rational or irrational? Go ahead and pause the video right now and let me know what you think. Be sure to explain your answer in your notes. Okay, so on a calculator, you should have figured out that the square root of 42.25 is 6.5. And 6.5 is a number that ends. It's a terminating decimal, so therefore it is going to be rational. All right, let's move on to the next problem here. 102 has 6 more decimals. Okay, so let's read this. It says every rational number can be written as a fraction, that is, as a ratio of 2 integers. Since 0.78 is described in words as 78 hundredths, it's not a surprise that the equivalent fraction is 78 over 100. Use what you know about place value to rewrite each terminating decimal as a fraction. Check your answers with a calculator. Okay, so just based on that example, I want you guys to, the example of 0.78 is the same as 78 over 100. I want you guys to give me the fraction for each one of these decimals. We'll just do the first one right now. This one is going to be 19 over 100. So see if you can use that example to figure out what the rest are. Okay? Go ahead and pause the video and give it your best. Okay, you should have gotten these answers here. So pause the video if you want to double check your answers. The problem also said to check your answers with a calculator, so maybe you've done that already. But what you guys should be determining, if you're doing this correctly, is you're asking yourself, where does that last digit in your decimal, what place is it? What place value is it? So for example, let's take a look at problem B here. My last digit is that third digit in, so that's the thousandths place, right? So that last digit's in the thousandths place, so my number is basically going to be that same number without the decimal, but divided by 1,000. Okay, same for problem C. That 1 is in the thousandths place, so I'm just going to put it 1 over 1,000. Let's take a different example here. Let's look at problem E. E is in the tenths place, so I write that 3, and I'm going to divide it by 10, because it's in the tenths place, right? Let's go back to problem A, the very first one. That 9, that last digit, is in the hundredths place, so I just rewrite 19 divided by 100. Okay, let's move on to 103. 103, that's a typo on CPM's end here. So the number is not 0.57, because we already know how to convert that based on the last problem, but it's 0.57 with the bar over it, meaning it's 0.57, 57, 57, 57, 57, and it repeats forever. Okay? So she wants to be able to write it as a fraction, and she's not sure how to rewrite it. She starts to rewrite it as 57 over 100, but she's not sure if she's correct. What do you guys think? Is she correct? Is 57 over 100 the same as that repeating decimal? Well, if you were paying attention on the last problem, 57 over 100 is 57 hundredths, and it should just be 0.57 or 0.57. Okay? So, moving on to question 104, it's kind of the same deal here. We're going to reverse our thinking. So 104 has 6 problems, 6 examples with these fractions. See if you guys can rewrite these fractions as their decimal equivalents. So basically the opposite of what we just did for 9-103. Okay, see what you guys come up with, pause the video, and come back when you're done. All right, welcome back. So you should have gotten these answers here for A through F. And I want you guys to take a look at problem D and F for a second here. So problem D and F, those are where students may make common mistakes because they see this as a 1 divided by 999. Sometimes they write their answer as 0.1 with a bar over it, but it's if you think about it, it's that 1 has to be in the thousandth spot, right? So sometimes it's better to kind of imagine this as 001 divided by 199 because there are 3 digits in 999. There should be 3 digits in your numerator as well. So 001 is what's going to be repeated. And the same for problem F. If there's 3 digits down below, there should be 3 digits up top, so 019. And that's what's going to be repeated. Okay. So question G says, what patterns did you guys see between the fractions and their equivalent decimals? So hopefully you guys, as you guys are doing this, you can observe the patterns that I was just talking about, and then you're going to use that pattern to answer question H. And question H is another typo on CPM's behalf. There should be a bar over that 0.24. Okay, so write a fraction for that, and when you're done with that, go ahead and convert 65 over 99 as well. Okay, pause the video, come back when you're done. All right, so you should, looking purely at patterns, you should be able to come up with these answers on your own, okay, without the use of a calculator. So for 0.24 with a bar over it, you should figure out that it's 24 over 99. Look at everything that we've been dividing with. It's been dividing by nines, right? Whether it's 9 or 99 or 999, these are all nines. So to continue that pattern, we're going to divide 24 by 99. Why 99 instead of 9 or 999? Is because the number 24 has 2 digits. So because it has 2 digits, there's going to be 2 nines, right? And then the same thing for 65 over 99, it's going to be 0.65 with a bar over it. All right, let's move on to 105. 105 is basically explaining how all of this works. So CPM wants you guys to talk with your group and have these meaningful discussions. And because it's a little bit different, it's going to be difficult for us to do that today. I'm just going to explain why this works for you. Okay, so instead of you having to have a conversation with yourself, we're going to explain using the example of 0.57 with a bar. So let me set this up for you guys. All right, so as you know, 0.57 with the bar over it is the same thing as 0.5757575757, repeating out forever. So let's take a look at the right side here. If I have 0.575757 forever and ever and ever, I can go ahead and for now, let's call that x. Okay, so if I call that x, what happens if I multiply that same x by 10? Well, if I multiplied it here on the left by 10, I've got to multiply it here on the right by 10, right? So as we know, when we multiply by 10, actually let's multiply it by 100, not 10, 100. As you know, when I multiply it by 100, I multiply it by both sides, all I have to do is move the decimal 2 places over, right? So my new number is going to be 57.57575757, right? Goes on forever and ever and ever. ... And all I did was I multiplied both by 100. I multiplied the x by 100, I multiplied 0.5757 by 100. And so now the question is, what would happen if I subtracted it? Right? If I subtracted 100x minus 1x, how many x's would I have? Well, I would have 99x. And then if I subtracted 57.57575757 minus 0.57575757, what am I going to get? Well, as you can see, these two decimals should line up perfectly. Okay, and all of this right there would cancel itself out, and I would get 57. All right, so if I were to solve for x now, going back to our basics in algebra, I'm going to divide both sides by 99. And that's why when I My final answer is x equals 57 over 99. So whenever I divide it by 99, I'm going to get those repeating decimals. Okay, so that's why it works. So 105 in question C says use the same strategy to rewrite 0.98 with a bar over it as a fraction. Be prepared to explain your reasoning. Okay, so in your notes, I want you guys to do this problem on your own, very much like I just did this example that you saw. And then in a short sentence, just explain your reasoning. Okay, welcome back. So here's the work that you should have done. Multiply both sides by 100. And again, we're multiplying both sides by 100 because our last digit is technically in the hundredths place. Okay, you're going to multiply by whatever placement, that place value, if that last digit is in. So if it was 0.985, I would add, that would be in the thousandth place. So I'd multiply both sides by 1,000, right? So basically, you should just been able to explain every step of the way on how to do this in your notes. Okay, let's move on to the next problem. 9-106 says show that repeating decimals are rational numbers by rewriting them as fractions. So at this point, you should have enough experience to try to rewrite each one of those as fractions. Pause the video, come back and see what you guys come up with. All right, welcome back, and there are your answers. Again, it's the same digits, going to be divided by how many nines? Well, you're going to ask yourself, how many digits do we count here? There's 2 digits, a 4 and a 2, so there's going to be 2 nines. For problem B, there are 3 digits, so there's going to be 3 nines, right? Problem C, 2 digits, going to be 2 nines, and then problem D, there's only 1 digit, it's in the 10th place, so it's going to be divided by only 1 9. 107 says to create a number line. So in your notes, what you're going to do for this one is you're going to create a number line, and you're going to place the numbers where they belong. So my hint to you is choose -3 all the way to +3, right? And halfway should be 0, then I've got 1, and I've got 2, and then I've got -1 and -2. I want you guys to basically draw an arrow, like where are these numbers going to be, okay? Well, you wouldn't have to draw an arrow because you guys can just write them in your notes. So take as much time as you need. It says try to do it without using a calculator. Some of you guys are going to jump straight to a calculator, and you're going to learn nothing from this because anybody can use a calculator and figure this out. So if you really want to learn, try to do it without a calculator, see what you come up with. It's not going to hurt you. And then if you want to check your work, use a calculator, okay? So again, pause the video, come back when you're completely done. All right, welcome back. This is what you should have gotten. So it would have been easier if you converted all of them to decimals. I'm not sure, I think CPM said for you guys to do that, I didn't mention it. But in decimal form, here are where the numbers go. Okay, so -9/5 is really -1.8. -1.8 is right there. It's closer to a -2, right? And then the next number is -0.75. Again, it's right there. It's already in decimal form, so I didn't have to change anything. The next number would be 2/3. 2/3 is 0.666666666 forever. The next one is pi over 3. Pi over 3 would be 1.047, which is a little bit more than 1. Should be about right there. 2 1/4 is 2.25. Should go right there. And then the square root of 8, using your estimation skills that you learned from the previous lesson, is closer to 3. So it's 2.828 ... Okay. All right. So let's go to our last problem today. It says 108 says without using a calculator, write the orders from least to greatest. Again, practice your estimation skills. Do not use a calculator. You'll check your answers in a bit. Okay, so pause the video, rewrite the numbers from least to greatest, and would be much easier if you would put them in decimal forms again. All right, and here's our answer. And least to greatest is going to be 9.099. which is already in decimal form. Then we've got 3 pi, which is really 9.42, dot, 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 goes on forever. Square root of 99, estimated it to be about 9.5, or excuse me, 9.95. Then it's 10, it's just 10, it's a whole number. And then the next one would be the square root of 102, because the square root of 100 is 10, so the square root of 102 has to be bigger than 10, it's 10.099. And then we have 1.1 times 10 to the first, which is just 11. Okay, so that wraps up the lesson for today. I think a good closing piece would be for you guys to just understand how to convert or how you would write a repeating decimal as a fraction. So if you can explain in your notes how to write a repeating decimal as a fraction and how to convert that fraction to a repeating decimal, basically going back and forth, you have a solid, very solid understanding of today's lesson. All right, hope you guys have a great day, and I will see you soon.